Hello all. Now here we've got the T5 calculator paper, the first part of your booklet, and I'm going to do the last past paper, which is January 2014. So it's this bottom one here. Okay, and in this video I'm going to explain the first 5 questions. So I'm going to do question 1, that's question 1, question 2, question 3, question 4 and question 5 in this part of the video. So when you're going through, when I'm going through this now, will you have your past paper open in front of you and see how I'm working them out and see how you get on against that? Okay, so I'll shorten this down here. Okay, and this is the first page. That's just to show you that it's the January 2014, and it's the T5 paper 2. Okay, so that's just the first two. I'll just take that back and put it there. Okay, make that a bit smaller. Okay, right. So here we have question 1. So if you open your question, you can see it says, write down the temperature shown on the thermometer. Okay, now the key thing to note is this. You have to work out what these are going up. So that's 31, and that's 32, and that's 33, and that's 34. So each one of these is going up 0.1. So for example, that's 31.1, 31.2, 31.3, 31.4, 31.5. So we finally get our way over it and we can see it, that's 33.8. Okay, now the second part of the question says, write down the weight shown in the arrows below. So the key thing again then is to work out what each one of those are going up on. So you can see from 0 to 1 there's a couple of ticks in between it. So the one in the middle, for example, that one there is like, that's 1.5. The one that's sort of halfway between the 2 and the 3 is obviously the half. So each one of those is going up 0.25. Now that's 0.25, 0.5, 0.75 and 1. So every one of them is going up 0.25. So if you look here at this information, that's 6, and then 6 on your calculator, take away 0.25 gives you an answer of 5.75. The key thing to remember is that we must make sure that we know what the barriers are, what each one of those wee ticks are. So this one here would be 14.5, 14.75 and 15. Okay, now the second part of the, just get rid of that. The second part says an extra 3.5 is added. Draw an arrow to show the total weight now on the scale. So you've got your 5.75, which is there, plus your 3.5. So if you put that into your calculator, you get an answer of 9.25. Okay, so 9.25 is, remember we said that's 9 and then they're going up 0.25, so 9.25 is exactly there. Now guys, that's 3 marks for that. Okay, so we've got to be very careful we understand what the barriers are. Okay, if you think about it common sense, 14, that's 14.5. So what's in 14 and 14.5? That's going up in 0.25s. Okay, so that's how you do the first, that's question 1 done. So I'll just shorten that down. Okay, now this is question 2. Now this is a bit more difficult. It says, Jean and Rose each have a bag of sweets. Jean has an equal number of toffees, mints and fruit sweets. So as we said before, the best thing to do is to try and visualize what it looks like. So if I make that a bit bigger, they each take one sweet at random from their own bag. So we can imagine drawing like a small box here. So this is Jean, and this here is Rose. Okay, now let me get rid of that one. Okay, now it says here that Jean has an equal number of toffee, mints and fruits, and Rose has twice as many mints as fruits. Okay, so Jean must have, get a different colour, 1 toffee, 1 mint and 1 fruit. Rose has twice as many mints, so that must mean she has 2 mints and 1 fruit, and she has no toffee sweets, so she doesn't have any toffee at all. They each take one at random. Who's more likely to take a mint sweet? Well, if you look here, Rose has 2 mint sweets. Joan has only 1 mint sweet, so Rose has got twice as many. She has 2 out of 3 chances, so Rose has got twice as many. So the answer for that question is Rose has got twice as many as Jean. Now, part B, who is more likely to take a fruit sweet? Explain your answer clearly. Well, they've both got an equal chance because Jean has got 1 fruit and Rose has got 1 fruit. So here I've just written down here that Jean has 1/3 mint, 1/3 toffee and 1/3 fruit, where Rose doesn't have any toffees. But like, it's much easier to see it in graphical form. So sometimes always remember to try and draw something that you can see, particularly when you're doing probability. Okay, so that's the end of that question. Moving on to the next one, which is question 3. Now this presented huge problems for a lot of people. Okay, so I'm going to run through it. Remember, you have a calculator, so it is important that you use your calculator, but that you do the sums first. You must do the sums first and then use your calculator. So Jill has a part-time job, that's fine. The pay is £7 per hour, that's clearly important. She earns time and a half on a Saturday. Time and a half means that you get your £7 plus your half of 7, which is £10.50. So she gets £10.50 on a Saturday and double time on a Sunday. Well, double time means double the time and double the money. So on Sunday she gets £14. So last week she worked 6 hours on a Monday. So 6 hours times her 7 gives her £42. On Saturday she works 6 hours. So it's 6 hours times the £10.50 because it's time and a half. 7 and 350 is £10.50, which gives you 63. Sunday is double time, so she does 4 hours on a Sunday. 14 times 4 is 56. Then you add these up on your calculator after you write them down to give you 161. Now guys, that is, how many marks is that? Let me see, that is 5 marks for that. We've got to make sure we get them all right. Okay, that's question 3. Question 4. Apologies, it's just cut off at the end here, but it says, if you look at your paper, it says every car salesman with new autos earns a basic monthly supply of £1,800. In addition, they earn a bonus of 75 for every car they sell. This is the key thing here. Can you understand this? This means your total monthly salary, what you get in a month, is a standard 1,800 plus the number of cars you sell times the bonus per car sold. So Eileen is a car salesperson, with new autos. She sold 15 cars. So 15 cars in April. That's the number of cars is 15. Work out her total monthly salary. Okay, now she gets her standard £1,800. That's what she gets. Plus the number of cars sold is 15 times the bonus. Well, the bonus is 75. So 1,800 plus 15 times 75. Now please remember you have a calculator bid mass. The calculator will if you put that sum in the whole way, the calculator will do this multiplication first. Okay, so we need to make sure we do 15 times 75, which gives you 1125, plus your 1,800 to give you a monthly salary of 2,925. Okay, now part B. Jim is another car salesperson with new autos. In May, his monthly salary was 1,525. Now, this is clearly going to be a reverse one. Work out how many cars. So this time we need to work out not the money. We need to work out the number of cars that were sold. So we're going back on ourselves because here we know that he got 3,525. In this other question we had to work out. So we know that he's got 3,525. If you go back up to the formula, you write in 1,800, so that's 1,800, plus the number of cars we don't know, and that's multiplied by 75. So 3,525, to get that we use this number plus whatever the number of cars times 75 is. So you can do it quite, you can sort of have you can guess it to a certain extent. You could start, for example, with like using 20 cars. So you could do 1,800 plus 20 times 75, and that would get you quite close. Or else the more sensible thing to do was, well, first of all, take this 1,800 over, because then that just leaves you with the number of cars sold times 75. So if you take that minus that, gives you 1,725. If you divide it by 75, it gives you 23 cars. Or else, if you weren't too sure, just start picking some numbers, multiply by 75 to give you 1,725. Okay, that's how you do reverse. So reverse means you take this number, which is set in stone, and you work out the number of cars sold times 75 to give you this here. We're using the formula. So if you put this plus 23 times 75, that will give you 3525. Two ways to do it, just to reiterate. You can either sort of guesstimate, you can start putting some numbers in to work it out, or you can bring that over. Obviously when you bring it over it becomes take away. Then you work out how many cars times 75 gives you the new number. Okay, now that's quite a difficult question, but those are the sort of questions we've got to get answered correctly. And then the last question in this part of the video is question 5, and it's got to do with rotation. Now, when I'm talking about rotation, I'm going to just talk quickly about shapes when I'm on the topic. A square has symmetry 4 and rotation 4. There's two shapes that have got 2 and 2. A rhombus has got 2 and 2, and a rectangle has got 2 and 2. And a parallelogram has 0 and 2. Now they need to be learned. They're the lines of symmetry and they're the rotations of symmetry. Now you've got to know those guys. Now in addition to that as well, a regular hexagon, as you know, has got it's a 6-sided shape. It's got 6 lines of symmetry and rotation 6. A pentagon has 5 and 5. An octagon has 8 and 8. They're all the regular shapes have both the same in lines and rotation. Now to get to this one, question 5, it says shade one square and one triangle in the diagram that completes the one line of symmetry. Okay, so the easiest thing to do is to just have if you can imagine, if you use a bit of tracing paper, if you trace that end, you'd have to realise that it would have to go that end, because that would have to double up on it. So if you trace that shape, you realise that this bit's missing. Now this is where tracing paper comes in, particularly for rotation and symmetry. So if you put this, you need to work out that this is the answer for, it has to go exactly there. Now I said use tracing paper to help you with this question. So if you trace this, and you can imagine moving it round, you'd realise that when that goes there, you move this round to there, this will go there, and then this will go there. So you use tracing paper to work out exactly. When you're doing any type of symmetry or rotational symmetry, ask the examiner for tracing paper, and they'll help you. That'll help you. Well, of course, they'll give you the tracing paper, and then that'll help you work out rotational symmetry. But please learn this information. A square has 4 and 4. A rectangle and rhombus have 2 and 2. A parallelogram has no lines of symmetry but rotates twice. And the regular shapes like hexagons and pentagons and octagons have the same as the number of sides. Okay, so that's the first 5 questions explained. I'm now going to explain questions 6 to 10 on the next video. Okay, so here we have the second part of the video. It's questions 6 to 10 we're going to do now. It's still T5 paper 2, January 14, which is part of this booklet here. It's the T5 calculator paper part 1, and it's still this question here. So I'm now going to tackle questions 6 to 10. Okay, now let me put this back up a little bit smaller. Okay, so question 6. Mary has 63 tiles, but they're square, and she wants to arrange them into a rectangle. Write down the length and width of 2 different rectangles that she could make. The key thing is that the rectangle must have a square of 63. So in other words, you have to think of 2 numbers that multiply to give you 63. That's the key thing, because it's square. Alright, so we've got, well, there's 3 options. You can do 1 times 63, you can do 3 times 21, or 9 times 7. Either one of those will give you a square, when you multiply them, give you an answer of 63. So that's what they're talking about with the square. So for example, if I had them in the square of, I don't know, let's say 30. If I had them in the square of 30, you could have had 3 times 10, you could have had 6 times 5, or you could have 2 times 15. So watch out for that question when you see it. It's about square tiles. So those are the answers: 1 times 63, 3 21s, or 9 7s. Okay, and bear in mind you've got a calculator, so just go through your numbers till you find numbers that give you 63. Okay, now question 7. 700 people arrive in a bus station. and has to be transferred to a local airport. The buses, the maximum they take is 48. The key question is how many buses are filled. It's not how many buses are needed. So most people did 700 divided by 48, which gives you 14 and a half buses. Now, you do need, I've seen a lot of people writing 15 as the answer. Now, that is correct. You do need 15 buses. But the question doesn't say that. The question is how many buses are filled. So there are 14 full buses. Okay, that's how you just be careful of that question. It doesn't ask how much is needed. It asks how much is filled. Now, part B. Excuse me. Calculate the number of people who have to travel in the last bus to ensure all 700 are there. So we have 14 full buses, and we know there are 48 on the bus. So 14 48s give you 672 on the calculator. Now, there's 700 people in total. There's 672 on the 14 full buses. So if you subtract those, that gives you an answer of 28 people that are left in the last bus. So we've just watched for that type of question there. So that question has got to do with not how many is needed, how many buses are filled. And once we work out how many people are on the 14 buses, these are people that are on the last bus. Okay, so that's question 6 and 7. Okay, now let's go to question 8. This is one of our favourite ones. This is about imperial and metric conversions. So, Bradley was cycling at an average speed of 25 miles per hour. Convert the speed into kilometres per hour. Now, please be careful. This has nothing to do with speed, distance, time. This is a conversion from 25 to 25 mph to kilometres. So we have got to remember our key information that we always do. So this is our imperial measurement, miles, and this is our metric measurement, kilometres. Now, remember here, how do we get from miles to kilometres? We divide, remember I said divides at the top, divide by 5, multiply by 8, and here we divide by 8 and multiply by 5. So what you need to do then is this. You need to understand you're at miles per hour. So you're starting here and you're going from miles to kilometres. So you're dividing by 5. So 25 divided by 5 equals 5 times the 8 equals 40 kilometres per hour. And that, boys and girls, is how you do that. You need to remember that. You have to remember that. The other things to remember is, of course, pounds, LPS, pounds to kilograms, and we have pints to litres. Now check your information to work out what that is. Go back over it. Okay, and that's the end of question 8. Alright, now let's go to question 9. Question 9. Now this is probability. All probability adds up to 1. 0 is impossible, 1 is certain, 0.5 is evens. All these numbers here must add up to 1. So the probability that crisps are bacon is, when you add these up here, this and this and this and this, it gives you 0.72, and 1 take away 0.72, if you like 100 take away 72, gives you 0.28. That is a calculator question. Please do not make any mistakes with that. Calculate the probability. Now, yes, at 0.3, just be wary, 0.3 is 0.30. If that was a known calculator, you couldn't put that at 0.3. You need to make sure all these numbers have two decimal places after them. Now, calculate the probability that crisps are not vinegar flavour. Well, not vinegar flavour means this, and this, and this, and this. So you can either do 1 take away 0.12, or I would prefer to do this, plus this, plus this, plus this, to give you an answer of 0.88. If the question had been, calculate the probability that crisps are not sausages, then it's this, and this, and this, and this. Okay, which would be 0.75. Now, even though part C is not, I'm going to make up part C here now, because this is the one I see all the time. If I say there are 600 crisps, how many would you expect to be beef? Now look, what you need, this is, I've seen this all the time. This means you take the probability of beef and you multiply it by the number of crisps. So that sum is 600 times 0.05. And if you go to your calculator and put in 600 times 0.05, gives you an answer of 30. So you would expect 30 crisps to be beef. Now, that's how you, if you were looking to get cheese, it'd be 600 times 0.3. If they were looking to get bacon, it'd be 600 times 0.28. When you're looking to find how many crisps or how many of something, it's the probability times the number. You've got to remember that, case. Okay, that's question 9. Okay, and then that moves us on to question 10. Now question 10 is a speed distance time graph. Okay, so I'm going to split it up. This is the first part, and if you look in the next part of your page, you'll see that's the second part. Okay, so I'll just make that a bit smaller so we can do the two beside each other, hopefully. Okay, now, Katie went on a cycling trip from her home. The diagram below shows the distance time graph for her complete journey. Now remember I said the first key thing you've got to do when you're doing any graphs, particularly any graphs at all actually, is to work out the barriers going across here and going up there. You'll definitely need them during the exam. So for example, I know that's 20, that must be 10. So each one of these must be going up in twos. 2, 4, 6, 8, 10. Each one of them lines is going up in twos. That's why that's 30, that's why that's 40, and the one beside it would be 42, 44, and so on. These here are going up in 0.2s. So that's 0, 0.2, 0.4, 0.6, 0.8, and then 1. You've got to work out that. You'll need that for later on. So what's happening here? Here's what's happening. Katie's heading on the bicycle. That's her house, and she's heading up there. Now she's clearly travelled for 10 kilometres. And this here is always time, and that's taking her 40 minutes just to read. So that's what's happening. She's obviously had a stop, and then this is her coming back home. Okay, just if you look at the graph, what part of the graph is she going the fastest? Well, clearly the fastest is always the steepest. So she's going faster here than she is going there. It's clearly the fastest is steepest. Okay. Now question A, what is meant by the horizontal line? Probably she stopped. She stopped for a break, she stopped for a puncture, she stopped, whatever. She must have stopped. How far did she travel in the first 30 minutes? Well, that's 10, 20, 30. You must draw the line up. You hit that line, you read across. That's why this is vitally important. They're going up in 0.2s, so that's 7.2, 7.4. That's between 7.4 and 7.6, so the answer must be 7.5. Okay, now, part C, that's why I've brought this along so we can see. Part C says, how long did it take her to travel the first 4 kilometres? Well, the first 4 kilometres is across there, again, coming down to hit the graph, and you'll see it's hitting at the number 16, because those are going up in twos. So that's got to be accurate, you have to have 16. Where was Katie after 120 minutes? Well, 120 minutes is here, so lo and behold, she's up, take a break, she's home. So 120 minutes, 2 hours, she's back home. Now, here we go. What was the average speed for the first 30 minutes? Now, the average speed for the first 30 minutes. Well, you can of course do our graph. So we're looking at average speed, which is this here. So it's distance divided by time. Now, the distance for the first 30 minutes is 7.5. So that's 7.5 divided by time, which is 30. Now 7.5, 30 is 0.5. Now remember I told you to get rid of decimals, you multiply that by 2. So that's 15 divided by 1, which gives you an answer of 15. Okay, and that's quite a tricky question, but that's the answer, 15. Now, question... I'll get rid of that. Okay, now, question F. At what stage of the trip was she travelling at the fastest average speed? So that's the fastest. So the answer is the first stage, because that's the steepest line. That's the steepest line, so that's the fastest part. Now, this is the key question here. After how many minutes had she travelled at a distance of 14 kilometres? Now, after how many minutes had she travelled a distance of 14 kilometres? Well, let's look at her distance here. So this here is her up to 10 kilometres, which takes her 40 minutes. Then she's had a break, which takes her to 60 minutes. So she's still only travelled 10 kilometres. She's still another 4 to find. So another 4 kilometres takes her down from 10 to 6. Okay, so that's at this reading here, at that reading there, that's her 14 kilometres. 10 and her 4. So you'll see here at that point there, I've drawn a line down and I've seen that that's 84 minutes. That's how she travels 14 kilometres. If you wanted to find if she travelled 12 kilometres, that's the 10. And then here's another 2. So that would be her reading at 10 kilometres. If you wanted to find out what she done in 15, 10, and then 5, which is there. So that's how you use the distance speed time graph for them questions. Okay, hopefully that was useful. The key thing to remember for any graphs to do with time or anything, or any particular graph, is to work out the barriers here and here. You will definitely need them for the questions. Okay, that's questions 6 to 10, and the next video I'll finish the rest of the questions for that paper. Thank you. Okay, so this is the last part of the first paper. It's questions 11 to 13, and it's still T5 paper 2, and it's the front of the booklet is of course this T5 calculator paper part 1, and it's paper D, January 14. Okay, let me put that up in the corner. Get rid of that and get the first 2 questions out, which are probabilities. So question 11 is a probability question, and this is the top of the next page. Just make that smaller. Okay. So here we've got an octagon, and it's got 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's got 8 numbers. And you have to really fill in this probability line. And this is 0, which is impossible. This is 1. You can see you need to break them into 8s. 1, 2, 3, 4, 5, 6, 7, and then that's 8 over 8. So when you're counting probability, you don't include this line, but they're all broken into 8s. I think that's the key thing to know. Okay, that's the half, 4 over 8, that's the 1, and that's the 0. So the probability of the spinner landing on the number 10, well 10's impossible, 10's not there, so that has to be 0. But you must write down the letter, which is A. You wouldn't write down 0. Part 2. The probability of the spinner landing on an even number. Well, an even number is the numbers 2, 4, 6, 8. So there's 4 of those. That's 4 over 8, which is a half, which is E. Now it doesn't mean E for even. That's just E because it's E. Alright. The probability of a spinner landing on the number 3. Well, how many 3's is there? There's just one of them. So that's 1 out of 8, which is part B. And the probability of a spinner landing on a multiple of 4. Well, multiples of 4 mean 4 times tables. So 4, 8, 12, 16, 24. 4 and 8 are on this spinner here. That's 2 numbers. 2 numbers. That's 2 over 8. So 2 over 8 is part C, letter C. Okay, now, the second part here is important. This is over the page. The spinner is spun 60 times. Key. How many times would you expect it to land on a number greater than 2? Greater than 2. So the numbers greater than 2 are 3, 4, 5, 6, 7, 8. So remember, when we're doing probability, when you're looking to find numbered answers, it's the number, which is 60, multiplied by the probability. And the probability of getting these numbers is 6 over 8. So that's 60 times 6 over 8. So that means 60 divided by 8 multiplied by 6. So if you do 60 in your calculator divided by 8 multiplied by 6, it gives you an answer of 45. And that's how you know, that's how you get the answer for that. How many times would you expect it to land on the number 1? Well, the number 1, if I had to say the question for that, then the number 1 has a probability of 1 over 8. So if you're multiplying it by 60 times, that would just be 60 divided by 8 multiplied by 1. So that's how you deal with those type of questions. Remember, those probability types of questions, when you're asking how many times has something happened and how many times would you expect it, you take the probability and you multiply it by the number. Okay, that's a key thing to remember. Okay, now that's question 11. Let me put that back up there. Question 12 is a ratio question. It's fairly straightforward because we know with ratio what we do is we add up all the parts, we divide the big number by the parts to give us an answer, and we multiply it by the parts. Okay, so we take this 8 and then we divide 292 by 8, which gives us 36.5, and we multiply that, and we multiply that, and we multiply that. Now, a lot of people lost 1 mark, because when you put that in the calculator, it gives you 36.5, and that gives you 109.5. But boys and girls, this is money. We must put in 0. 36.50, 109.50. You've got to be very careful with money that you put in the 2 decimal places. Otherwise you'd lose a mark for that. And then that leads us lovely to the last question, which is a question that's got to do with mass. Mass, density, volume. Monkeys, driving vans. Okay, now this type of question, there's a key hint here. If they're asking you to find density or mass, then you must find the volume. Now, generally speaking, to find the volume, the volume is always the area of the front multiplied by the length or the height. They generally, I've noticed, have always given you the area. So to find the volume, all you do is you multiply the area with the front of it, which is 60, times the length, which is 23. And that gives you a volume of 1380 centimeters cubed. Now that's a good hint. If it was a normal volume question, you'd find the volume as normal. So for example, if it was a normal volume like this, you'd find the area of the triangle, which is base times height divided by 2. 4 2s is 8, so that would be 4. Multiplied by, say, 10, which would be 40 centimeters cubed. That's a normal volume question. But a real hint is, if it's a mass and density volume question, to find the volume you multiply the area of the front times that. This normally would actually be given for you. So you multiply them 2 numbers to give you that. Now, you're looking to find the density. So you cover density on the triangle. So that's mass divided by volume. The mass is given as 8,600. The volume we've worked out to be 1,380. So mass divided by volume is 8600 divided by 1380, which gives you an answer of 6.23. Rounded to 1 decimal place is 6.2 or 6. And that's how you deal with those sort of questions. So I'm going to say again, for mass, density, volume, you must calculate the volume. You must do that. That's the first thing you must do. And a real hint is that you multiply the area. They'll normally, touch wood, give you the area, which is great. And all you do is multiply by that. Write that sum in somewhere so you have the volume written. Then you cover the density, because we're looking for density. So it's then mass divided by volume. So mass is 8,600 divided by our volume, which we worked out at 1380, to give you an answer of 6.2. If we were looking for mass, if we didn't know mass, that would be density multiplied by volume. If we were looking for volume, it'd be mass divided by density. Remember the key phrase, it's monkeys driving vans. Picture a monkey driving a van. That question will appear at the tail end of the paper. A mass, density, volume. It's a wee bit like the speed distance time triangle. Okay, so just to reiterate, with that type of question, look for the area, multiply it by the length, that gives you the volume. Once you work out the volume, you use your triangle to work it out. So for example, if it was something like this, if it was, let me see if I change my pen here. If we had something like this, trapezium base prism, and let's say the area of this front was, 50, and the length of it was 10, then the volume of that would be 50 times 10, which is 500. If we knew the mass, they normally give you the mass. If the mass was 11,000, then to find the density, density is covered, so mass divided by volume, so that would now be 11,000 divided by 500, which we worked out, and then that gives us an answer of 11%. 11. Let's just hit the calculator. Gives you an answer of 22. So the density for that would have been 22. Be very careful. Go back over that in your mind to be clear what that question is involving. Mass, density, volume means generally calculating the volume first. Okay, thank you.